So this is just a function that happens to have an exponent. This is an exponential function because the variable is the exponent. Okay. If I had to solve for x in this problem, what would I do? Like what's if you take the square root? The inverse of x squared, the inverse of squaring something is a square root. Any idea what I would do for this one? Anyone remember, like way back, not in this class, but in other classes, what the inverse function for an exponent is? For an exponential function? Yes, you know.
Fraction?
No. No.
Don't you raise it to the what you call it?
Sort of.
I don't want to say it and it sounds stupid.
You're not gonna sound
Then
stupid.
tell me and I'll sound stupid.
You don't you like flip the power and then raise it to the higher?
That would be, okay, close. That would be if it was like this. That would be flipping the power, right? But still, that's just a function with an exponent. On this.
Would you take the negative of whatever it is so that it's like, you know what I mean?
Yes, it's like reciprocal? No. Actually, what you
That's
would
the word I
do,
was thinking.
yeah, reciprocal, that's what you're looking for. The inverse of an exponential function is a logarithm. Ooh, that's supposed to be an H and an M. H and M. Here we go. Logarithm, yeah. You'd never guess that, I know. Okay. Logarithms and exponents are inverses of each other, okay? Just like multiplication and division, one undoes the other, or addition and subtraction. If you add 4 and then take away 4, it was like you didn't do anything at all. So, oh my goodness, okay. Say that we have y equals b to the x, okay? And y and b are numbers, and I'm looking for x, okay? So this is an exponential function. You can change it to a log function to find out what it, to be able to solve it. Which, let me just say, I know that for just a minute, it's not going to make sense because you still don't know how to do a logarithm or what to do with it. But just get how to write it down, and then we'll start seeing what to do with it, okay? But first, we're just going to see how to interchange them back and forth. So I'm going to write this up here, and you're going to be like, yeah, I still don't know what that is. But that's okay. For a couple minutes, it's okay to be like, I still don't know what you're talking about. So if you have y equals like, I don't know, 16 equals 4 to the x. That's what we have right there. So I'll put some real numbers in there. We all can look at that and go, that's what? What should that x be? 2, right? Okay. But let's just pretend that we didn't know that. And we had to use a logarithm to figure that out. Okay? Remember, this is called your base. Okay? That's still going to be your base. You're going to say, well, log base b of y equals x. So log base 16 of 4 would equal x. So do you see how undoing this exponential function would then turn around and give you what you're missing? That would give you the answer. See, when I undo this, what I was missing then becomes the answer. Okay? It's okay. Just wait a minute. It's okay. Yeah. Or what switched on purpose? Oh, log, yeah, that's still supposed to be the base. Sorry. Log base 4 of 16. Yeah. Yeah. What was missing is now the answer. Yeah. The base is still the base.
What part is the log?
4.
say log base 4 of 16. That's how that works. Oh. So let's say, let's do some real numbers. No, not yet. Not those big numbers. Let's say we have 125 plus 5 to the x. Now I want to change this to a log. Let's say log base 5 of 125 equals x. What would this one look like as an exponent, as an exponential function? So that's just interchanging it, okay? That's just going back and forth. That's how you go back and forth. Logarithms help you find the power that gets you to that number. These are easy. Hopefully you can look at all these and just figure out what it would be. 2, 3, 2. We're going to get into some that are a little bit. So I'm going to give you some to try. Try these. Let's see. 3 squared. I'm moving the variable around. Ooh, here's one. A to the b equals c. Write those 3 problems as logarithms. Okay, so I'm going to write log base 3 of what? 9 equals 2. Okay. What's the base here? So log base 5 of x equals 4. Fantastic. How about this one? What's the base?
A.
Alright, so log base A
C.
of C equals B. You might want to keep these two together, like star them, because that will tell you where to put stuff. You can, when you're having to move it around.
How do you know what the log is?
How do you know what the log?
It's the number being squared. On Q, the exponents. That's what I believe. Given
You mean like
That's
what
part
is
of
the
it.
operation for a logarithm?
I don't even know, to be honest.
Okay, that's okay. A logarithm really is the opposite of an exponent. So if you take an exponent, if you take something to a power of x, the logarithm can tell you which one it does. How do you find it? Well, thank the Lord above, we find it using a calculator. The calculator will tell you exactly what it is. When I was in high school, we weren't allowed to use these calculators. We had a chart. And that's the thing, unless someone tells you what it is, you don't know. We would have to, like if we had, like let's say we just had log base 2 of 7. And we have to find out what that equals. You have a calculator that will tell you that. Like that. We had, in the back of our book, we had a chart. And we had to go through the chart and find it on the chart. And like, it had thousands of numbers on it. Find it. And that's how we had to get our answer. But even before the chart, oh my gosh, I don't even know how to use these things. Miss Wells does. I have that, see that yellow thing like across the cabinet at the top? Okay, that's called a slide rule. And I really don't know how to use it at all. I've never had to use one. Miss Wells told me that it was faster than a chart, except that I don't know how to use it. Can you reach that to get that down? Yeah, you probably could. I'll show you what it is, but again, I can't show you how to use it because I don't know how. But anyway, you had to, you had to somehow line up the 7 and the 2 and whatever was there, the numbers going like straight down told you what the logarithm was.
Like the spell's probably knows what to do before.
So we went from an exponent to a logarithm. Now let's go back from a logarithm to an exponent. So let me give you some logarithms, and I want you to write them in their exponential form. Let's say log base 2 of 8 is 3. 2 equals log base 10 of x plus 5. Log base e of x is 4. Alright, so try those three.
See.
What would this one look like as an exponent?
2 to the third equals 8.
Okay. 2 to the third equals 8, or 8 equals 2 to the third. Either way, it's perfectly fine. Alright, what about this one? Okay. What about this one? Okay, wait, what? Okay, great. Okay, let's talk about some basic logarithm properties. These are basic properties, so we're not expanding anything. Log base b of b equals 1. Okay? Log base b of b equals 1. So you can think about why. Well, if you switch this around, you're looking at b to the first equals b. That makes sense. Okay? Log base b of 1 equals 0. So you're looking at b to the 0 equals 1. Log base b of b to the x will equal x. And that's because b to the x will equal b to the x. This one's actually really useful when we do start solving them, because if you can get the base here and this to match, you like knock them out and that exponent's your answer. So what's written in black is the property, and what's written in red is the reason why. And then the next one is sort of an inverse function. B to the log base b of x plus q equals x. And this is just because you had inverse functions, you are composing inverse functions. I have some tissue over here. Is that what you need by the printer? By the ginormous paperweight right there. Or none.
Like, we should take to the middle of the
It
field and
holds
be
that
crap
down,
on
I
it.
guess. Yeah. Like office space. Alright, does everyone have these written down? No? Function. Function, yeah, inverse function. Okay, so what does this equal? Log base 8 of 1. What would that equal? Look at your properties we just wrote down. Yes, it would be 0. That, see? Log base b of 1 equals 0. So log base 8 of 1 would equal 0. How about log base 5 of 5? What's that going to equal? What? 1. Yeah. Log base b of b. And these two match. The answer is 1 because this is what you're looking at right there. So log base 5 of 5 is 1. How about log base 2 of 2 to the 4th? What's that? Nope. It's going to be 4. Yeah, it's going to be 4. Yes.
Can you go back so I can get down?
To there.
Yes. So how do you get 4
Right here, this function, or this property, when those bases are the same, we equal the exponent. So 2, base 2, 2 to the 4th, they're gone, and it's just 4. Yeah. Why is this not moving together? Why is it moving? Alright, one more. 3 log base 3 of 7. What's that going to equal? 7. Yes.